Hi all, today we are moving to more problems on section of solids. So the first question is a square prism which is resting on HP on one of face, n face with its rectangle face is equally inclined to VP. Okay, so if the n face is equally inclined to VP, you have to start with the base edges which is equally inclined to XY line in top view. Equally inclination means 45 degree inclined to XY line. So you start with this line and this line which is 45 degree inclined to XY line. So you can take any convenient distance from XY line, and initially you draw a line which is parallel to XY line, and from that line you locate any point, and from that point you can draw this line which is inclined 45 to X line, also this line inclined 45 to X line, and complete the square. Okay, and draw the corresponding front view. Then after that, the condition given in the question is a section plane which is perpendicular to VP and inclined 70 degree to HP cuts the solid and passes a point on the axis 50 mm from the top. So 70 degree inclined to HP means if the section plane inclined to HP means that section plane can be represented as a line in front view. Okay, so the section plane inclined 70 degree to HP means which is inclined 70 degree to XY line in front view. So that line can be represented as vertical trace in the front view. Okay, so with that line passing through a point on the axis 50 mm from the top. So locate a point on the axis 50 mm from the top, and to that point you draw a line which is parallel to XY line, and you draw the section plane which is inclined 70 degree to XY line. Okay, 70 degree to XY line. And after drawing this section plane, you can locate all the section point. So for that, you can see that the section plane passing through a point here, and that point lies between the point 1 and 2 and 4 on the right side. That means the section plane cuts 1, 2 and 4, 1. Okay, because this line represents the front view of 1, 2 and also the front view of 1, 4. Okay, up to this portion of front view represent the front view of 1, 2 and 1, 4. That means the section plane cuts 1, 2 and 4, 1 or 1, 4. Okay, so there will be two section points here. One point is on 1, 2 and second point is on 1, 4. Okay, similarly here you can see that this line represents the front view of 2B and 4B. So there will be two section points here also, and this line represents the front view of BC and CD. So this section line cuts here, and there will be two section point here also. Okay, so initially we are locating section point on the visible edges. So the first visible edge is 1, 2. So the first point here. Then we are moving to this line, and here the visible edge is 2B. So the second point is on 2B. Then next visible edge is BC. Okay, so third point is here, and next we are locating the point on the invisible edges. That is, the fourth point is on CD and fifth point is on 4D. Okay, fifth point, and last point is on 1, 6. The last point, sixth one. Then to draw the sectional top view, you can transfer all the section points into corresponding edges. The first point is on 1, 2. So transfer this first point into 1, 2 on into this line. Okay, then second point is on 2B. So transfer this point 2 into 2B. So you can locate the point 2B at this point. Okay, then third point is on BC. So transfer this point into BC. Then fourth point is on CD. So transfer this point into CD here. Okay, then fifth point is on 4D. So transfer this point into 4D. You can locate the fifth point here, and last point is on 1, 4. Okay, so you can locate the point here. Now after that, you can draw the true shape. So there are two methods to draw the true shape. The first method we have already discussed in the previous video lecture, and here we are going to discuss the next method, and this is the simple method, and you can follow this method. Okay, so draw the true shape. You measure the length of the section plane within the solid. Measure this line and draw that line which is parallel to XY line. You can take any convenient distance from XY line. Okay, and also you can take any convenient distance from front view also, and draw this line which is parallel to XY line, and locate all these points by taking the correct distance. Locate all the point here also, and draw a project line through point 1, and also a line which is parallel to XY line through point 1, and locate the first point. Similarly, draw project line in the downward direction from here and also from here, so that two line will meet at at this point, will meet at this point, and you can locate point 2. Similarly, locate 3, 4, 5 and 6. Then join all the points by dark line and has this section. Okay, so this is a way to draw the true shape of the section. Here we are drawing the true shape because the section plane is inclined to HP and the sectional top which is obtained here is not the true shape. That's why we are drawing the true shape. And also when you draw the front view, the section which is removed by the section plane, or the portion which is removed by the section plane, should be represented by using thin line. So for that, when you draw the front view initially, all this line should be thin line. Now, and after locating all the section points and drawing the section plane, you can represent the section which lies between the observer. We are looking this object from the top, so the portion which lies between the observer and the section line, that is, this portion should be represented by using thin lines, and you can draw all other line by using dark line. Okay, so initially you draw this, all line should be thin line, and after drawing the section plane, you can represent the portion which is retained by using dark line. Okay, we are moving to the next problem. Here the problem is a Penel pyramid which is resting on HP on its base with one base at perpendicular VP. So you can start with one base at perpendicular X line either on the right side or on the left side. Okay, then the section plane passing through a point on the axis which is 15 millimeter from the base, which is inclined 45 to HP and 15 millimeter from the base. So locate a point on the axis 50 millimeter from the base. This is the base. So from the base, you locate a point on the axis 50 millimeter from the base, and draw the section plane which is 45 degree inclined to X line. 45 degree inclined to HP means 45 degree inclined to X line. So for that, through this point you draw a line which is parallel to X line, and through that point you can draw the section plane. Okay, and locate all the section point. Here you can see that the section line cuts here, and this point lies between A and on the right side B and E. So that means this section plane cuts AB and A. So there will be two section points here, and here this line represents BO and EO. So here also we will get two section points, and here this line represents CO and DO, and here also there will be two section points. So we are going to mark the section points initially in the visible edges. That is, the first point is on AB, and second point is on BO, and third point is on CO, that is the visible edge, and fourth point is on DO. Okay, that is the invisible edge, invisible edge, and fifth point is on EO, and last point is on A. Transfer all these points into corresponding edges in the top view and draw the true shape as we are discussed in the previous problem. Okay. Next case is the section plane perpendicular HP and inclined 32 VP. Okay, so section plane perpendicular HP and inclined 32 VP means the section plane can be represented as a line in top view. Inclined to VP means that inclination can be represented only in top view, so that section plane can be represented as horizontal rays in top view. Okay, so this section plane passes through a point at a short distance of 10 millimeter from the axis. So just we can discuss how to draw the section plane. So for that, the section plane is inclined 30 to X line, and also that section plane should passing through a point at a shortest distance of 10 millimeters. So for that, initially you draw a line which is parallel to X line, that should be thin line, and draw another line which is inclined 30 degree to this line. Okay, 30 degree to this line, because the inclination should be 30 to VP. 30 to VP means 30 to X line, and that two line should be a thin line. And after that, you draw a line which is perpendicular to this 30 degree line at a distance of 10 millimeter. Okay, so you'll get a point here, and to that point you can draw this section plane which is parallel to this 30 degree line or perpendicular to this line. Okay, so this way you can represent this section plane. Then after that, you locate the section point. You can see that this section plane, either you can start from left side or from the bottom side or right side. Okay, so this section line cuts on AE. So this is the first section point, and after that you can see that this is a second point that is on AO, then third point is on BO, then fourth point is on BC. Okay, fourth point is on BC. So here there are four section points, and to draw the sectional front view, because the section is visible in front view, so we draw the sectional front view. So for that, you transfer the first point into AE. So this is the first point. Transfer this point into A dash E dash. So we will get first point here. Second point is on AO. So transfer that point into AO. third point is on BO, transfer that point into BO. Okay, fourth point is on BC, so transfer that point into BC. That is, you get 4 points here. Join all these points by dark line and hatch the section. And to draw the true shape, you measure the length of the section plane within the solid and draw that line which is parallel to XY line. You can take any convenient distance and locate all these points by taking the same distance. Locate 1, 2, 3 and 4. And after that, you draw a line through point 1 to meet the line drawn through 1 at a point and locate point 1. Similarly, draw a line through point 2 and also the line from this point parallel to XY line and locate point 2. Similarly, locate 3 and 4. Join all the points by dark line and hatch the section. The hatching line should be thin line, evenly spaced, and the distance between this line should be 2 or 3 millimeter. Okay, parallel to each other. That should be thin line. Okay, and here the portion which will be removed is the portion which lies between the section plane and the observer. So okay, when we look at this object, the position of observer is here, so the portion which lies between the section plane and the observer is this portion. So this portion should be represented by using thin line. All other lines, okay, that is the portion up to from 2 to O, then from 3 to O, then CO, etc. Should be represented by using dark line. Okay, so this way we can draw the true shape and the sectional front view. Okay, the next problem is cone. Cone which is cut by a section line which is inclined 45 degree BP and 10 mm away from the axis. So the case is same as in the previous problem. Inclined to VP and 10 mm away from the axis. 10 mm away from the axis means that distance should be the shorter distance. So initially you draw the top view and draw the corresponding front view. So initially draw the circle, that is the top view of the cone, and divide the circle into any number of equal divisions. Say 4 number equal division, 8 number equal division, or 12 number equal division. Normally we are dividing the circle into 4, 8 or 12 number equal division. Okay, here the circle is divided into 12 number equal divisions. Okay, no need to divide the circle into 12 number equal division. You can divide the circle into 8 number equal division. That's enough. Okay, or 4 number equal divisions. Then you can mark all the point. Here the points is represented in the clockwise direction, or you can represent the points as in the anti-clockwise direction, as we are discussed in all cases. Okay, so the section plane here, the section plane passing through a point at a distance of 10 mm away from the axis. So the second method to draw the section plane is, in the previous problem we are drawing this way. So here we are using another method. Either you can follow the previous method, or the next method is you can draw a circle of distance 10 mm, because the short distance should be 10 mm. So draw a circle of distance 10 mm, and you can draw the section plane which is inclined 45 degree to XY line, and that should be tangent to this circle. For that you can draw a line 45 degree inclined to XY line here or here, anywhere on this space, and move the scale parallel to that line, and when that line become tangent to the circle, draw the section plane. Okay, and mark the section points. Here the first point is on BC, on the base. Second point is on BO, then third point is on AO, fourth point is on then LO, then fifth point is on KO, next point JO, then on this point. So you'll get 8 section points. Transfer all the section points to corresponding edges in the front view. Okay, when you transfer this 6th point, you cannot directly transfer that point. You just rotate that point into GO, this line, and project that point into front view of the corresponding G dash O dash, and transfer that point into the corresponding edge. Okay, and you draw the true shape as we are discussing in the previous problem. Okay, so just you can divide this circle into 4 or 8 number of division to draw the sectional front view and corresponding true shape. That's enough. Okay. Okay, I hope you understand all these problems. Okay, thank you.